Everybody. Okay, let's try this problem from the OpenStax book, chapter 4, number 45. So it's a projectile motion problem. So you just think about all the formulas in the world that you know, right? Then you know these. Right, for x and for y. And velocity. I'll just number these. Okay, so this first, how high above the edge of the cliff does the rock rise? So of the formulas you know, what pertains to this question? So it's like, how high is this right here, over here? So that has to do with, like, if you look at the velocity of the rock, it's kind of like this over time. At the maximum height over here, the velocity is horizontal. So that means, let me pick coordinates. So we could say the origin is here and go like this, or you could say maybe the origin is here and go this way. It there's infinite choices. So whatever you choose, you're correct. So based on the way I picked my coordinates, I'm saying the y component of the velocity is 0 at the maximum height. So Vy is 0. So that ties to equation 4 that I wrote over here. I'll just jot it down over here. Okay, so this is 0 at the maximum height. And then let me just fill in the rest. Because I picked this is x and this is y, v naught x, based on my choice of coordinates, is v naught cosine theta. V naught y is v naught sine theta. And then also gravity is this way, right? So then the x component of the acceleration is 0. The y component of the acceleration, y is this way, would be negative. Right, so this would be negative g. This is not universally true. This is for this particular choice of coordinates, like this. Okay, so v naught y would be v naught sine theta. Ay is negative g. And now let's take a look at what is known and what is unknown. So v naught, 30. Theta, 53 degrees. G, I know it, 9.81. T, I don't know. So there we go. So by writing this, now we know the time that the rock reaches its maximum height. How high is that? Look at these formulas, which has to do with height. This one, number 2. So I'm going to pick that one. Okay, so that's the height we're looking for. Why don't I just call it something? I'll call it h for height. Okay, so h, that's what we're looking for. This is 0 based on how I picked my origin. V naught y is v naught sine theta. T. Ay is negative, so negative. And now same, like what's unknown? I don't know this. I don't know time. But look at, now I have 2 equations, 2 unknowns, which means I can solve this for time and then put that here and here. All right, so let me just do that. T, so v naught sine, so there's squared, minus 1/2, so there's a 2 in the denominator, t squared, v naught squared sine squared g squared. So g over g squared can cancel. Let me just erase that. And look at this, like v naught squared sine squared over g. V naught squared sine squared over g. Then I can factor 1 minus half. So the answer is, here we go. So that's part A, the height above, so the maximum height above the edge of the cliff. How far is that when at the maximum altitude? So in other words, how far is this? I'll just call that something d for distance. So we already know the time that it's here. So just take that and plug it into horizontal distance, which is here. All right, so take this time and plug it in right here. I missed. Right here. And AX is 0. Right, this is 0. And this is 0. So that's it. So part B, I'll jot that down. So for part B, that distance is v naught x, v naught cosine theta, t, which I get from right here, v naught sine theta over g, plus 1/2 ax t squared, but that's 0. So then here we go. So it's v naught squared sine theta cosine theta over g. Okay, let's try this one. How long until it hits the ground? So, similarly, here's the cliff. It lands on the ground. So what's significant about that? So we know something about where it hits the ground. We know that it's 100 meters, right? The cliff was 100 meters high. So if the origin is here, we know the vertical position went from 0 down to negative 100. So that's right here. That formula, let me jot that down. Okay, and then this is negative 100, right? That's where it lands over here. That's 0. V naught is 30. The time, we don't know. Acceleration, negative g. See, so there's only one unknown here in this entire formula. The time. So that's the only unknown. So solve for t. It's just quadratic. This is 0. So let me rewrite this. Sine minus gt. So let me just move everything to one side of the equation. Okay, and then we're trying to solve for t. Let me get rid of this leading coefficient. So I'll just multiply everything by 2 over g. Okay, and then quadratic formula. Okay, so now I got the time that it lands here. So that's part C. And then now, what's the range of the rock? So meaning the horizontal displacement here, from here to here. How far is this range? So that is, we can just use like which of these 4 formulas has to do with the horizontal position? This one right here. So let's use that one. So I'll just say range. AX is 0. And then we started at 0. And we know V naught x is V naught cosine theta, range, t, and we got t right here. Just put it right there. Well, technically, we have two values for t because it's something plus this and then something minus this. Why are there two values? That's like you throw a rock and then it goes and lands over here. That's forward in time. If you could go backwards in time and teleport through a rock, it's like it'll be here, and see how this forms a parabola? So we're not going to pick the physically impossible, like, negative time. So just pick the positive value of the two, and then that goes here, and then we got the range. Okay, and then last one, horizontal and vertical positions at these three different times. Horizontal and vertical positions means these two. And we know everything except t. Well, AX is 0, right? So who cares? So just plug in these values for time into these two, and that's it for part E. Okay? So I hope that was helpful. Keep on studying, and then I'll see you on the next video.